Hello! The circuit in the left side, marked with letter A, will work just fine with smaller rectified DC voltages. The circuit in the right side, marked with letter B, will work fine with high alternative voltages like the mains 240 volts AC. For some very obscure reason, a circuit will blow up its two LEDs, and my suspicion it has to do with the switch is used. Even in the end of the video, I do test it connected to 240 volts AC and it appears to work okay. But when I actually added the actual switch, it blew up faster or slower many more LEDs. Faster from a few switches, the green one, and slower the red one from a bit more number of switches. After some discussions on the All About Circuits forum, their official answer was that it must be a reverse, and here is the quote, reverse breakdown or over voltage for LED, diode, and possibly the resistors. End quote. And I am believing their answer. It's a very good answer, but I also personally believe it's because some contact sparks that are being created in the switch itself, and they create some deadly spikes for the LEDs, especially for the LEDs. The other components, they did survived. They were not affected at all from my observations. I didn't know all of this when I started this video, but now I am putting it here on YouTube because it shows some interesting details of how I work, the tools and the materials I work with. But keep in mind, this A from the left circuit was abandoned after the real switch tests, and the B circuit from the right was the used one in the end. Thank you very much for understanding, and happy watching the building of this wrong A circuit. Yes, I'm building a small circuit here, and a very small one, and a very cute one at 220 volts. Where is not specified there? Here it is. This is actually the circuit. It's a switch. That one that is turning on and off is having 3 contacts. These are 2 LEDs. Probably it will be a value much more higher than a 100 kilo ohm, and the diode, and pretty much that's it. And what will do, so when it is on, switch to on, this switch, this will open light this LED, and when it will turn off, will light this other LED, but the other one will get off. So one on, one off, and then one off and one off on. This will be green when is on and red when is off, pretty much. And I will use the 3 millimeters. I already used the size for this circuit. This is how is the final circuit, how it will be implemented. This is exactly the same circuit like here. And now I want to show you how I'm building. This is cardboard. I have a cigarette package with SIDA, AIDS, protect children and blah blah on it. It's a Kent, the best cigarettes in the world.
This is a sponsored video. No, it's not. But yeah, pretty much I have a ton of cardboards. These are the remnants, actually the cuts that remained, and I put them aside after a size. You know, if it's a good size, I put it aside, and I have different thickness and of cards and different cardboards and different strength of the cardboards. Some are weaker, some are stronger, and this, for example, is very strong. This one is also very nice to put your finger on it. And also I have bigger, like this. And much more bigger, but I don't keep it close near. So this is a cardboard. I have no idea from where. It's just a piece, and pretty much what I'm doing is where are you? I'm using the plastic tweezer, because if I'm using the metal one, is highly magnetic, and see everything is catching on it, and I don't like it. Even though I demagnetized all my metal tweezers, they still catch a little bit, and I don't like it. So I get used to use the plastic one, and it's pretty much what I'm doing. And this is, like I said, this is a cardboard with pieces of metal bended, and I will show you my process. Nobody asked me, but I will show you anyway, because yeah, I have already bent some of them, but usually I cut them and form them as I need them. And if this is too longer, I will reshape it. Actually, I have one here already prepared. Is when and I'm comparing what I'm doing right now. I'm comparing if the length of the a small metal sheet, I don't know how to call it, is the same with the length what I need here in the. This is, I draw it with my pencil, like this, you know, and this is a needle that you saw, you know, and I have a bunch of them also in a cardboard. This is a cardboard. This is a piece of paper, but thicker. And I have some this one, and see, this one doesn't have an ear anymore. The ear is broken. Like this ones are okay, and this one as well. This one as well. It doesn't have an ear, and this one didn't have an ear, exactly like this too. And I made my punching needle with it. I pretty much took some plastic. Let me show you. I know I'm diverging, but you know, I like bigger movies. So this is plastic, which is category of 02 polyethylene, no? Polyethylene, PE. And I have 3 assortments of plastics. That's 02, this one 01 PET, which is the beer plastic, and this one 5 PP. PP is highly used in consumables, the things that you eat. They are stored in PP plastics. I didn't know, but I get. So I used that 02 plastic PA, I think it was, and I melted it, and I originally when I made this, it was bare like this. It was without anything, you know. And when I was pressing with my finger, it punched me. So I don't have money to buy expensive shit, so I made it. I made my shit, and I took that PA plastic 02 and melted. Originally, I put a little bit like a ball and flat, and then I flattened it because that ball was also punching my finger when I was pressing in very hard materials like leather. Or I don't remember it, but I had some moments when I had to use a needle in very hard surfaces, and even that ball was punching very hard in my finger. It destroyed the it was damaging my nerves and my muscles there. So I flatten it. I get the idea to flatten it here, and when I'm pressing like on a button. And then I get the idea to make it longer like this. But then I realized that it will not get inside this box that I have here. So I had to restrict the length of the plastic to the length of the box, and I elongate it a little bit, and now it's very much resembling with medical needle. You know, those that already have a plastic shape like this, exactly like this. You will think this is a medical needle, but it's not. It's just a sewing needle, but with plastic on it. So yeah, this is a fun idea that I had. Very practical. Very practical. It's not looking beautiful. It's odious. It's very bad looking. It's very inesthetic, but it's extremely practical. So that's my that's where the idea got into. So getting back to this, I'm using my needle and I'm punching the cardboard. I hope you can see anything. If I'm keeping my hand, let me do it like this maybe. Like this maybe. I know it's a shadow. So I'm punching it pretty much where those little ears of the metal sheet will get into. And right now I have a series of holes, not that big. You see, it's barely pushed through the cardboard. But now what I'm doing, I'm putting it like this. I'm enlarging the hole, and I'm doing like that, like this, you know, because the cardboard is very fragile, and it will, yeah, you see. And now I'm always using my my tweezer because my fat fingers are not letting me do anything precise. And yeah, see, and it fitted. It fitted because I took the measurements before. It's not fitting probably perfectly. Hey, come on, like that. You see? Ta-da! And now all I do, I'm bending the ears. You see, with my nail. I'm pushing with my nail, and also I'm using my I don't know how it's called. This tool. A patent is called in my language, but in English sometimes if the material is very strong, like this one, this is very thick, and I cannot bend it with my finger, so or with my nail. So this is how I'm creating my boards. And then I will add the components that I already draw here. Let me point with my trusty knife here. This is a chirurgical knife, very old chirurgical knife from 1800, something like in that period. It's very old, but I love it. And I love it because it never broken. Is intact. It was never repaired, so it's good. So here are the LEDs, these two circles. This is the resistance the resistor, and here is the diode. I even put a marker here to know where to go, the direction. Here I have the input. I will solder the two wires directly here on this input, and from this output I will go outside. This board will be for, oh, I have time, will be for this. Unfortunately it's a big shadow there. Yeah, so this will be the switch, and when I will turn off, it will lit the red LED, and when I will turn it on, the green LED will open. So I will make some holes. I'm not sure where the location will be, but this is before. This is before. I am thinking here somewhere to actually see them when I'm switching, and then and this switch actually had only 2 pins. The motherfuckers. Well, it has only this pin and this pin originally, and I took my trusty sheet metal that I have here, and I cut a little bit like this, and bend it and formed that third pin. It was having the option, it was having the hole in it, but they didn't put a metal pin there at all. But the hole, it was from from industrial, they cheap out with 1 pin, motherfuckers. So I had to make myself a pin, and it's working actually right now. In this moment is using that pin that I made. I leave it alone, that original one that it had, and now is making contact on my made up pin that I built it inside it. I had to open it, of course, and remade it. So this board, these 3 locations or tabs that you see here will also have the metal pins on them. Tabs will connect to that switch, exactly like in the diagram here. So these are the pins of the switch. The switch will come here. I didn't actually measure. I use my IO meter. I use my eye only. I didn't measure this, but probably I will put some wires or something. We'll see. And I will have to be careful with 220. This is mains, switching directly on mains, and I think it's very cool project. I mean, it's cool because something is lighting up, but the functional nobody really needs. It's perfectly like it is right now, but well, it's like bells and whistles, I'm adding bells and whistles. A cat is having a bell on her neck. This is what I'm doing right now myself. I'm adding a little bell to the cat to know where it is. This circuit actually, it is an indicator light LED, for to indicate if the current is on the wire. Yes, that's it for this part. This is before soldering anything. Now is the construction. I showed you how I'm constructing it, so be happy. Leave a fucking like. And yes, we will meet when I will put the components and make some tests with it. All right? Thank you very much for watching until now, until here. So the board, my little board, is finished. I put all the pads, metal pads, exactly like in my sketch that I have there. Actually, this is the drawing of the switch and it's pins that are going into those pads, these pads here. And yes, I will here is a wire, here is another wire, and from here to here is another long wire, and the rest are the components. And yeah, it's finished, the little board. I'll show you the under, how it looks. So everything is bent, and it's safe, it's very safe. And I'm usually not doing this, but for sometimes in some projects I'm reinforcing with another cardboard the back of these things, especially because it's on 220 volts. You don't want to put your hands in the back of it and get a nice dance of electrocution. So I will reinforce it with this. Well, usually when you are having that inside it, is really no danger of putting your hands anywhere anywhere close to this little board. But you know, it's a good measure for idiots. And this is a very it's a bit more stronger. It's not that strong, but it's a bit stronger cardboard. You know, like those packages, and it will be glued to this part. So I will glue it like this, and it will efficiently isolate everything at once, you know, at least on the back side. And on the front side I will put the components, and we'll make a test and we'll see how it's working, and then I will mount it directly on the tool that I want to mount it. So yes, that's it for this little board. I've cut all the components and shaped them. Alright, let's see if I'm zooming in. Hopefully, let's see, until somewhere here. I'll make a sign. Yeah, it's a bit, let's see, it's a bit weird for me to work that far away, but yeah, it's let's see, like this. It's more centered. So here, okay, I'll make a mark there. So what I did, I have cut and bended all the components, and well, now I'm soldering them, and you will see how easy and fun it is to do it. If you like soldering stuff, well, this is your favorite channel. And of course they flow away. Alright. I hope I'm in focus. Everything is fine. Because this is a piece of copper, and as you know, it is highly conductive. I avoid putting my finger on it while I'm soldering it, because I will burn my finger. So that's why I'm using the well, when I don't remember a name or a word in English, I'm making a joke. Bam. So my circuit flow away. Here's my circuit. That's it. And let's see, not this, actually this one, because yeah, it's not that much of a big deal, but it's good to, even for small circuits like this one, it's good to have a reference. And of course, I'm blowing with my mouth. It's a yeah, the music is killing it. It's killing everything. Finally, they changed the rhythm a little bit. All right, so on this guy here, like this. So for you to understand, this is the first time when I'm building this circuit in particular. So I didn't repeat everything you see here at all. This is live and the first take, and it's pretty good, huh? So these are the wires, and it appears I didn't. Oh shit! And this, they come in. These guys are coming in. So how do I do this? How do I repair you without making too much mess? Yeah, a little bit more blob. There. Fucking hell. This pad, yeah, I have a big problem with some pads. And I think I have a bad luck. Oh. I have a bad luck with this pad in particular because, let's see, maybe I can repair it very quickly. Kind of, but sometimes they are treated. This pieces of metal is having a very slim coat of nickel, and that nickel coat is like sprayed. You know, it's a very thin layer of nickel. It's like it's deposited actually. It's a deposition of nickel, and that's very small deposition of nickel. If I'm burning it too much, will peel off, will dismember, will dismantle from the metal it's stick into. And if I'm putting fluider on it, I get under on the actual metal, which will not stick. That's the case of this one. But now I kind of put a big blob there, and it's stable enough for now. But it's not. Usually I'm switching. I'm taking it all out, and I'm making another one, and I'm But for the movie, this is a 100 kilo. It's actually having a text on it, and you can see 100 kilo. But this is a smaller value actually. I will use it as it is right now with this resistor, and I will use a bigger value resistor later after I will experiment. Right now I'm building and then testing. Don't run away. I'm building and testing the circuit. Because it has its complications, you must be aware of. So that this diode is like this. I already bend it in the correct position, and of course it doesn't has this it. It doesn't have the preparation. Always be prepared is my motto. So preparing, come on. And yeah, do you see? Where are you? Can you see it? Probably. Let's see. Do you see that blob of solder there? It's a big ball of solder, which is good. It means it's prepared. Always be prepared. Correct? And voila. Voila in France. It means yata. It means what it means in English is hello. Look. It means look. Voila. But I like to say voila. No? Yeah. Yeah, this is good now, but if I'm overheating it, that thing will peel off. Yeah, I think I will have to. Well, usually I'm relying on the insulation of this is copper wire, laminated copper, and this lamination, this isolation of the wire is it's pretty good. I mean, I can barely take it off with my knife. I'm usually scribbling with my knife, but I will add another insulation on the pin of the on the one leg of the LED that is crossing over it, over this wire. It will cross over it, I think. Let's see. Oh, I put the protective I glue it, the protective cardboard. I strengthen it. It's a bit more stiffer right now, which is good, but it's still cardboard, and also the LEDs, I'm always cutting a bigger leg for the plus and a smaller leg for the negative pin. It's a very good, very excellent hint to rapidly know which is plus, which is minus, so I will never fail in and these LEDs here are showing me they are going in that direction, so plus plus is here and minus is here, so like with the longer leg on these pins. So one pin here, I'm not sure which is switch on probably the top one will, when I'll press it down, it will make down. When I'll press it up, will make the up contact. No, it's okay. So the top will be the green, which is on, hopefully. And here is no problem, absolutely no problem with intersection of contacts. But I'm away from my marker here. But this guy here, let's see. Yeah, it's exactly between between the legs. It's exactly between the legs, that little wire. So I don't have to actually yeah, it might work. You cannot see it probably because I'm keeping my hands over it, but I'm telling you, it's good enough. And if I'm careful, yeah, I'll have to reshape it a little bit more. I probably like this. Let's see. Yeah. This. And it's that wire, which is isolated. This wire is absolutely isolated. I can actually melt a little bit of plastic here to further isolate it on top of this, put a blob of plastic and pretty much isolated, but it will not look nice, especially for the video. So I will make this tweak here, which I didn't thought on it. This is you've seen me building it. Actually, I will put this LED, and the problematic one I will resolve it later, just to show you until that problematic leg or pin. So this is how I'm doing my soldering, not with fancy tools or expensive shit, just the simple and efficient. Simple and efficient. This is how I like it, Do you like the music? DJ Theo is in the house. DJ Q12 is in the house. So yes, I had to reshape it a little bit more. Stick it here. And Bob's your uncle, no? This is how. I'm also blowing some air on it, cool it faster. Now I'm reshaping it on the spot. Pretty nice. And this guy, which yeah. Yeah, I will have to prepare as well. And sorry for not talking all the time. I'm always blowing air on the hot pins because it's better to to not let them be hot too much time. Yeah? Are you good? You should be good. You should be good! Yeah, he is good. Alright, so is this is maximum actually. Yeah, well, so yeah, actually I will zoom in after all. Let's see if it's focusing. Sorry for that. So you see it's a large, very large. So look here on this leg. Where are you? This leg. It's a very large gap between the leg and the tab and the wire and everything is pretty much in air. You see it? And yeah, it's safe. I had to bend it properly off camera. So this is the circuit completed on cardboard, you know, and with little tabs, metal tabs, and yeah, it's cool, huh? It's looking very cool. So pretty much when I'm closing these two contacts here, if I'm bridging them, it will open the green, and when I'm bridging these two other contacts with the switch, of course, the red LED will open and this one will close, signaling that is off, and this is signaling that is on. It's cool. It will be cool. It will look cool. You'll see. You will see. Trust me, it will be very cool. Okay, so I connected 10 volts. You can see it there. So 10 volts. And I've connected 10 volts, and I'm testing out before I will hook it up to 220. So let me close this. And here is the off. You see it? This is the off button. Press. And this is on. Pretty much. Yeah? Off and on. And it will stay in one state, in the off state or in the on state, all the time, pretty much. I mean, either in off, either in on state. And that's it. This is it. So that's how simple you can test it, even if it's for 220 volts, or even if it's with a large resistor here, the 100 kilo, and even higher than that, because I really don't want these LEDs to be extremely bright. I want them to be dimmer, not 100%. Okay, so this is it, and where are you? I'm looking at the camera. I'm trying to catch the thing. So yeah, it's looking very, very, very cool. I think it's very cool. All right, this is it. Focusing. All right, let's see, zoom. So it is hooked up to 20 volts, as you can see there. This is the wire going here. Nothing is lit because you have to actually make the contacts that I told you. Right now is in reverse. It is like this. That because the input, and I have to be careful. So right now I'm testing it. I'm holding it down with the isolation tool, and this is the conductor. Let's see. So this is on, and this is off. I have to actually make the contacts there, so nothing is blowing up, even if it's directly on the mains. Everything is safe. Like I said, probably I should add a bigger value, because these LEDs right now are a bit too bright, but especially the green one. Yeah, it's good enough. Alright, this is the test, and yeah, it's working. Actually, the same circuit is there for that white LED as well, and yeah, it's working directly from 220. Alright, this is the experiment, and we will meet again when it will actually